Hello, protocols, packets, and programs. Happy Lunar New Year. Welcome to the Year of the Wood Dragon, which is a cooler naming scheme than InfoSec uses for APT groups. Whether your own element is code, cloud, or cyber, may this year bring you good fortune. I will be celebrating the Year of the Dragon with lots of Dungeons and Dragons, which also has cooler names for creatures than InfoSec has for named vulns. Let's hope InfoSec does something cool this year. Which means this week, we chat with Christien Rioux about code scanning, a little bit of its history, a little bit of its techniques, and a lot of what developers would benefit from. In the news segment, LLMs improve fuzzing, shim weakens secure boot, more threat models for AI, so many more, another configuration file format, and more. Be cool and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
This is episode 273, recorded February 12th, 2024. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Mike, I'm here to do good. I hope you are too. I know it's a change for both of us.
The change for both of us. All right, we'll struggle through. Let's see if we can make it to the end. Speaking of other good things, don't let third-party risk ruin your Valentine's Day. It's coming up this week. Join Adrian Sanabria and Bill Brenner for understanding third-party risk by studying third-party breaches. What a lovely title. Adrian loves exploring risk through breaches and incidents. Bill loves thinking about third-party risks. And they love our partner for this webcast, Process Unity. Visit securityweekly.com/ValentineRisk to register for the webcast. You'll love it. Christien Rioux, also known by his handle Dildog, is a distinguished engineer at Lacework and the co-founder and former chief scientist for Veracode. Educated at MIT, Rioux was a computer security researcher at Loft Heavy Industries, and then at the company AtStake, he co-authored Loftcraft and the anti-sniff network intrusion detection system. He's also a member of the Cult of the Dead Cow and its Ninja Strike Force. He's also known as the author of Back Orifice 2000, one of the cool early remote access tools, and an author of The Tao of Windows Buffer Overflow. Hello, Christien. Thank you for joining us.
Hi, Mike. How are you?
Doing well. It's been about 2 years since you last joined us. Brought us some big smiles when we last talked about some of the projects you alluded to, Valid, and some of the work you've been doing. Since then, you've been doing a lot of other work on top of that around code security.
Absolutely.
And one of the things, code security is one of those things that we as an industry have been doing for decades. We're still finding vulns. We're still finding vulns that are 35 years old, in lurking about in C and C++ code. So how can we perhaps just do better? How can we do something cool this year from an InfoSec perspective?
Well, frankly, application security has always been a bit of a estimation process. When we look at code, what we're trying to do is assess the likelihood that something is wrong with the design or the implementation of a program from a non-contextual point of view. So static analysis, for example, is a mechanism where we ingest a program and look at it and try to make models of what could possibly happen in a program. Those models are inherently estimates. This differs from a lot of other more scientific measures of quality, where we actually run programs and see and measure how they perform. Security has lacked a very accurate measurement mechanism for a very long time. We've been searching as an industry for a way to measure security like we measure other forms of quality. You can tell how much memory a program uses. If it's Chrome, it's already blown up 2 gigabytes of memory, right?
Exactly.
So you have some empirical measurement you can do. Security often is just measured as something after the fact, after an incident. The way that we're thinking about this, and I think the sort of next generation of AppSec is really about connecting the sort of shifted left parts of development with the reality of what is happening in production environments and the actual runtime of programs. Historically, security practitioners that are looking to secure things have only really looked at the data, the models of programs, and security practitioners who are reacting to security incidents are coming from the production side naturally, where you've got these two worlds, and somewhere in the middle they need to meet in a way where the data can line up. You've got production environments where you have all this logging and you have like measurements going on. The question is, how do you use that to improve the accuracy and reduce the amount of guesswork being done when writing code or debugging it or scanning it for security vulnerabilities? Coming up with a way to share that information so we can reduce the amount of guesswork involved will greatly improve the accuracy of tooling and the applicability of findings from security tools.
Yeah, and that concept of a feedback loop, that's a core engineering principle that as you pointed out, InfoSec is still perhaps struggling a bit with a science aspect of it for measurement and engineering aspect, even in just what are good architectures, references, stuff like that. So what does a good feedback loop look like then? Because you can log lots of things, but that doesn't necessarily mean you're logging useful things.
Yeah. Well, honestly, there's you have to categorize the kinds of assumptions that you're making. Sometimes it's about things like exploitability. If you're reporting a bunch of issues, you see tools that are high in false positives. The question is, who's determining that? There's usually a human being sitting there that looking at it and getting frustrated. You see, a lot of static analysis tools have this manual element, and that's the feedback loop today. When you're talking about feedback, it's you get results from a tool, human beings review it, and they make a call. They make this sort of judgment part about whether it's accurate or not. As something moves toward a science and repeatable, measurement, the tolerance for human error in that process, as well as requiring human attention and effort, needs to go like way down. We don't need human beings in the loop for everything in development. We've actually, as the industry in general, the whole development and computer industry in general has been moving away from having human beings involved in the pipeline in the middle steps. People write code, it runs through a bunch of automated tests, CI pipeline, integrations, all of that before it ends up in production. And we've been moving toward a sort of continuous deployment for basically everything. A lot of companies, a lot of software is written where features end up in production the same day that they're written because the testing is so mature. Security hasn't always been able to participate in that pipeline with the same frequency as other tools for various reasons.
So this is interesting to me. So I love the idea you're talking about bringing this to a science.
Yeah.
But thinking through that that CI pipeline as it is today, almost nobody does 100% unit test coverage, right?
Sure.
It's difficult to get that last 1 to 0.5%, what have you. And my head started struggling to think through, if I can't do that with a unit test, how do I do that with AppSec?
Well, maybe you don't.
From the point of view.
Maybe you don't. And there's a reason why we don't get to 100%.
Yeah.
You don't have to get to 100%. But you do have to use the right tools for the job. And the thing that's going to get you to 80% is not necessarily the thing that's going to get you to the last 20% for any of these things. as someone who's written a lot of static analysis tools in my time, you can focus on doing things like broadly and quickly and with low overhead for configuration. Or you can focus on making tightly integrated tooling that utilizes, say, the output of a build and requires human review and tuning and deep analysis, things that take a while to search a graph. You've got this sort of dual, like two ways of judging these tools. And the 80% case is the fast, broad scanner, for example, that can get to literally everything in your enterprise, all of your organization's code, but might not go as deep, but definitely doesn't require as much configuration or any at all. You can't get to 1,000 repositories if you have to manually handhold the scanner for every single one. But you can do a broad, slightly more shallow, but more general, unconfigured scan on code and get to that 80%. That last 20%, maybe 10%, is going to require more direct involvement with developers and security engineers to be able to triage those last items. But what you want to do is eliminate the low-hanging fruit from that process. If you want to get to 98%, you don't do it by using the same tool for the job everywhere, because they're just not built for that. I spent years getting beaten up for either having a tool that was too slow for some or required too much handholding, or a tool that wasn't deep enough and had false positives or whatever. And really, it's because we've been thinking about things like static analysis and security tooling as it needs to be one size fits all. And you're not going to be able to make both masters happy if you're thinking that way. So there's different workflows. You've got the highly automated workflows that you can't configure. If you were to, you'd be spending thousands of man hours just configuring the tools. And then you've got triage that does require manual review, and that needs to be made painless and as accurate as possible, so you don't waste your time on false positives, right?
So what you're describing, and I'm curious to sort of dig deeper into this point. I'm not trying to annoy you. It sounds a little bit like you're describing an art, not a science.
Well, I think that where the line is between sort of fast and broad and deep and things that are deep and more accurate, that line is a bit of a fuzzy, like what's good enough. It's not that it's not scientific. It's that right now human beings are still the arbiter of what is good enough. You're asking a human being to be involved in this process. So I think over time it'll become more scientific when the human being gets factored out as much as possible. You want to make that middle section where a human being is suddenly involved in the process. You want to reduce that. You want to go from 80% to 90% to 95% automated. And the science here is going to be how much can we cram in to that completely automated part before we start to trade off false positives or false negatives or what have you. And the way to do that is to use more actual data, real measurements, not just estimates. Static analysis is inherently a superset analysis of possibilities. What is actually possible? You're searching like all of the possible things in the world. If you can reduce the amount of work you have to do and the actual amount of estimation you do by using real world data in that static analysis process, now you're approaching something where more work is doable in a shorter time frame, and these broad, fast tools could become more accurate.
I think that brings in that aspect of the engineering, or call it the applied side of the scientific approach. Okay. Because Christien, you have an extensive background at Veracode. You're familiar with source code analysis, yes. Background at exploit development, especially on Windows. if we start to talk about that superset analysis, or you talked about, you mentioned too, is this exploitable?
Right.
That is one of those areas of, let's set aside false positives, but figure out, it finds a lot of things, but do we need to fix this? Because this becomes a time prioritization. How does, what is that feedback loop, and how do we figure out perhaps a more scientific approach to, is this code reachable? Is this code exploitable? And even the distinction of those two dimensions, has consequences for how much work we might be putting on to developers that from their perspective might be like, well, this is a waste of time. This is a quality issue, but it's never going to be something that's going to hurt the running system.
Sure. Well, in general, as the industry has improved over time, and when I was at Veracode, I would have killed to have real world data, about actual application usage. But we started off trying to just model programs, and when you model a program, you don't really get a sense for the actual usage patterns of real humans, or what is in a large complex system, exploitability is tied to usage patterns as well as reach as the if let's say you use a fuzzer. I'll give you an example. That fuzzer could run forever and not find the one random control flow path that actually might be exploitable. In fact, a fuzzer is an estimate of actual usage of an app as well. You have this coverage problem, and you could identify all kinds of technologies that have tried to make the coverage of programs more accurate over time. In general, you alluded to, you said that unit tests don't cover everything, integration tests definitely don't cover everything, UI UX testing doesn't cover everything. There's a general problem of coverage analysis for programs. We don't know what control flow paths have been executed and whatnot. So, static analysis tried to solve this by superset analysis, but it added a ton of false positives in the process, right? It tried to say, is it possible for you to get from point A to point B? What matters just as much as that superset analysis of possibility is, what is the actual likelihood that we'll find all the conditions required to do that? And if you want to get to that 98%, you could start by looking at the real world traces of a program. Measure exactly what the control flow graphs and data flow graphs look like. Measure the actual call stacks and thread contentions and everything else about a program when it's running. Use the profiling information you have of the program actually running to shortcut the searching process. Because you could search forever. You could do data flow and control flow analysis on a static model forever. And that's just a halting problem, right? But if you're not going to search forever and you're giving yourself a time bound, you might as well search where actual execution is likely.
Yeah, get that app into the state that people get it into, which
is exactly.
A circular statement. But
there's no point in searching states that are definitely not reachable, but you don't know which ones those are. That's the halting problem, right? You don't know what states you can't reach. But you definitely know which ones are most likely to be reached. So start there. If you take that from a scientific standpoint, the way this manifests in real world practice is measuring actual applications while they are running is the missing piece. Security has suffered from an observability problem since day one. We haven't been looking at the apps until after they've crapped out. We're not using the data of watching programs. In every other industry, there's this maxim, you can't improve what you don't measure. Well, we're not measuring the actual program. We're measuring and, we're looking at architectural diagrams and trying to make a judgment call about, whether or not the bridge is going to fall over. Now you've built the bridge. you should be also doing stress tests and measurement and, after the fact, seeing if there's flexing in places that there shouldn't be. If there's chunks falling off the bridge, you want to be able to go back and revise the architecture to fix it up. This is not a fire and forget it thing. This is not we're building applications and they're out there and we had to get it right the first time. This is an iterative process. And you want to improve things over time, you have to make that iterative process as painless as possible. And you have to be measuring things that are actually truly useful. The way I see it, you've got three different personas here. You've got sort of this developer who's writing code, cares about a small piece of it, just doesn't want to screw things up, and is trying to ship features and not slow down because of security, right? You've got your security engineers who are going to be responsible for execution of security programs in an organization. They're feeding stuff back to developers, tool output, helping them triage things, doing false positive reduction, trying to build scripts and use tools to, provide low noise feedback. And then you've got your CISO types that are developing security programs and trying to measure if they're actually making things better. So you've got those kind of three different kinds of concerns, and they each have their own distinct measurements about what is actually progress.
And you mentioned CISOs. I did want to bring that in there because we're talking about the science aspect, engineering aspect, but CISOs, especially in particular, are probably bringing in that business aspect of, are we doing better? Was this investment, meaning we're bringing a dollar amount into this, whether it's developer time or just tool cost? So, what does that start to look like in terms of what a successful code scanning or secure coding, perhaps even program might look like?
At the CISO level, you're looking less at points in time. A security engineer, for example, is going to look at a point in time, like, we just had log4j or whatever. Let's look at our current state and figure out if we're vulnerable, right? Over time, the success of a security program is going to measure things like response times. It's not just about the number of vulnerabilities that you're bringing down. It's about being able to prioritize the things that are in flight and improving things like response time. And for example, like when you run a scanner, you get this point in time that says you have SQL injections in this critical library that through our attack path analysis shows that it's on a critical path from the API server or whatever. You find it at a certain point in time. The amount of time that flaw exists matters to the CISO. If you have too many things that have been around for 6 months, obviously your response time needs to improve. Being able to actually measure that the addition of a tool or a new process is improving the response time to issues, like reducing the amount of time developers take to start working on something, reducing the amount of time that an individual flaw exists, and then you've got different types of flaws, overall severity of flaws. You get a bunch of different measurements there. But again, for the CISO, it's really about measuring how security performance is improving over time. At that point, a human judgment call can come in from above saying that the program's worth it, the tools are helping, or they're not. But it's not necessarily visible to a developer, who's just worried about fixing this one bug that showed up on his plate.
Yeah, and actually fixing that one bug is one of those things that I always kind of, want to push back against, in the sense of, don't just fix, here's this XSS, here's the SQL injection. How did we do something that gets rid of that class of bugs? Mm-hmm. And I want to kind of reframe that into the question of, what kind of hope do you have, or optimistic future do you have for code analysis to find more interesting vulns? And here I'm thinking of like something that isn't just a simple cross-site scripting, something that isn't a simple, here's string concatenation. Probably is going to be SQL injection or some type of command injection, but maybe, and here I'm going to use a broad fuzzy term, like a business logic, something that's a vulnerability within basically those state transitions of the application that aren't based on invalid input. Is this type of feedback loop, is this type of code quality issues, are we getting better visibility into those types of vulns as well?
Absolutely. It's hard to quantify what is wrong at a business logic level without some human involvement. However, being able to measure what an app is doing in production, I mean, you got to think about apps. They, 10, 20 years ago, most apps were just an executable with some stuff like DLLs, and it was all kind of self-contained and ran on a single machine or something. These pieces have become smaller sometimes, but they've become more. There's a lot more pieces, and then most cloud applications, for example, are hundreds of moving parts that are dynamically reconfigured, and those things, keeping track of what it's actually doing is really hard. That observability has gone down over time. It actually was easier to just run an application with a profiler, record everything it was doing, and then look at it and then see, have we ever run this routine before? Well, you could just look at the profile and see how all the parts were connected together. Static analysis 20 years ago could tell you, because generally speaking, apps that were highly distributed in nature were not as prevalent. Now it's everything. Everything is highly distributed. All the parts are all over the place. But putting together the actual picture of what's going on, where that's a living thing, it's not like a static, like you've linked it, it's an executable, here it is. It's a bunch of different Docker images all stitched together, and they can all have different versions that are changing at once. Your view of the actual sort of execution and connectivity of your app without some kind of external monitoring mechanism that can sort of reverse engineer what your app is really doing, you don't have that observability anymore. So security has become a function of observability. And the more abstract the connections become between the parts of the business logic, the more that observability matters. And it's never been more important than in cloud security for us to acknowledge and use that information. You can't just get away with running a scanner on one repo anymore. You don't know what the ins and outs are until you see the big picture of how it's all connected together. You get that data, you make that data useful to the tools, and now we're talking. Now you're looking at like the whole application. I used to joke at Veracode that we played around with a model of pricing, which was per application. Sort of makes sense in a way, because we figured applications, that was like an executable in all of its parts.
And then the monitoring.
Then we talked to the customers, and they're like, "My application has 100 executables. We're just going to pay for one app." Turns out that the definition of application has been changing, and application security needs to change with it. It's no longer the same thing as it was 20 years ago, 10 years ago. The applications are way more complicated, and if you're not building models and tracking the data of today's applications the way they are actually run, you're missing out, and you're missing all of the critical context required to do it accurately.
There's a story we're going to cover in the news where an article in IEEE Spectrum, proverbial garage door opener, smart connected home type thing, from the garage door opener up to the cloud and back to the app, they're guessing is around 50 million lines.
Yeah.
So best of luck. But the question off of that, what I've seen a lot of customers, I'm sort of curious what you're seeing nowadays. Customers frequently don't want to put that observability in there, right? They're paying, particularly now in the whole cloud world, you're paying for those CPU cycles, you're paying for the memory and all the resources. Mm-hmm. They often don't want to say, they don't want to slow down their app or pay more for, on top of that. Are you seeing that, or do you think people need to change their point of view, or how do we deal with that?
I am actually not seeing that at all. I find that cloud applications have lots of different agents running alongside the actual application. There's been a lot of monitoring tools and log analysis, and security is just another form of observability at that level. Certain technologies have made that kind of observability easier for cloud-enabled apps. The rise of Kubernetes has led to making one-line changes in a Helm chart where you can monitor all of the activity on a node. It can be literally a one-line commit push, and then automatic deployment, and suddenly you've got a daemon set with an extra agent running alongside all of your nodes, monitoring what they're doing. That isn't hard to do. I think a lot of the pushback on things like performance, it matters to some degree. But if what you're getting is worth 5% overhead on CPU, and really your cost is network bandwidth or data storage bound, less CPU bound, then people will make the business decision that they need that data, they need that observability. As long as it's easy enough, people will do it. Now that they've got that, though, the question is, what do you do with the data? What do you do? How do you make best use of, say, runtime tracing or runtime observability? Yeah, well, what is actually possible with that data? Well, historically, companies like Lacework, where I work, have built tooling to display a polygraph, which is what we call our reverse engineering of your app. It's got a view of what the app is doing while the parts are connected. We do attack path analysis that says, you've got a entry point to your app here, and it reaches the database through like these things here, and maybe you've got some vulnerabilities along that path that we know about. Integrating that kind of detail with all of the actual static analysis tooling and all of the stuff that developers are doing, making that data useful outside of the runtime context is sort of the next big frontier. If you really want to improve the shifted left parts of AppSec, you have to be able to use that data that you get from the shifted right parts.
Yeah, and I was going to say, kind of to summarize how I hear you describing this, is that the old school static analysis was just, here's the repo, we'll either run it typically on the developer system, maybe on the build server before the CI/CD concept was around, but now we have CI/CD. But even just running on the individual repo could be necessary but insufficient in terms of, well, this is just one, microservice within a dozen other microservices, if not on the order of magnitude larger than that. So that right hand, if you will, observability is what has to be done. It sounds like for modern code scanning to be
right.
Useful.
The fact is that on the shifted left stuff, you've got the sphere of concern for developers is only a fraction of all of the pieces that are eventually put together. But if you don't feed back that how everything is connected into the tooling in a way that it can be used, you have to make assumptions. You have to make all kinds of weird guesses about exploitability or so many times at Veracode and in other walks of life for me, people have marked findings from tools that I've seen as just mitigated by design. You spend all day just saying, nah, this is not accessible. This is unacceptable. Why did a human being have to do that when you knew that it was an internal service that never actually received input from the outside world? You could have noted that this API was inaccessible. That knowledge is there, and it turns out that the overall structure of the stuff shifted right doesn't change nearly as fast as you think. It's one thing when you're like developing, and you do like a huge new push, and production is brand new. You don't have that runtime context history yet. If your app's been out there for a little while, and it's probably not changing so much that the data that
I've seen that. We're going to do a service migration. We're scheduling this for the next 18 months. Yeah, I exactly know what you mean.
So, stability, runtime has the property that you try to keep it stable. A secure system needs to be a stable one. And that very property would suggest that if you're measuring something in production, that incrementally, with some level of error, small, hopefully, that the stuff you're measuring in production is kind of like the stuff that is close enough to the stuff that you're developing on. That you're not inventing a whole new app in development each time. It's that you're incrementally modifying and changing programs, especially in the context of security. Almost for sure, like you can almost always categorize security changes as things that don't necessarily add features or change the intended function of a program, because security vulnerabilities are kind of defined as things that go against the intention of the developer, right? It's vulnerabilities or things that don't work the way you expect. That means a security fix should only bring things closer to the way things were designed, right? To improve the design. There are going to be those logic changes and things where, it was a fault in the business logic to the point that you've got to change how things are connected. But in general, the idea that the feedback loop, that you can use production data to improve, the things in development. That feedback loop can be pretty tight in most cases.
So one of the themes I always pick on is, is AppSec, maybe AppSec just needs to go away or change significantly? Because a lot of the observability I heard you describing is kind of an SRE approach, right? How stable is this? There's a lot of software quality you've mentioned several times, strongly agree. Security is just kind of an aspect of that. So as you're having these conversations with companies talking about static analysis, which very much has a security dimension to it,
yeah.
Is it what's the role of an AppSec team in this? Or perhaps better posed, how should the AppSec teams be changing to catch up with the rest of engineering disciplines that have these feedback loops?
Well, one change that I'm noticing is that the notion of an AppSec team is becoming something that only the really either heavily mature or very rich enterprises can afford. Security tooling needs to be made accessible to everybody. And developers are becoming their own AppSec engineers on smaller to medium businesses and individual, startups and things like that. You don't get to have an AppSec team that just does all the AppSec work for your organization unless you're big. And oftentimes they're going to serve multiple masters too. I've seen cases where the AppSec team doesn't just work for devs; it also works for procurement and other parts of the company where they're going to buy some third-party technology, and the AppSec team has to vet it.
Fill out this questionnaire, please. Yeah,
right. So you end up doing all kinds of different AppSec as an AppSec team. The question is, how can you make their life easier? Well, you can reduce friction with developers. Nobody likes to be the bearer of bad news. If you're going to do that, try to reduce the false positives on things, right? So there's that, but then there's also things like interacting with procurement. You got to be able to make judgment calls about third-party code and determine whether or not it's fit to bring into your organization, or if they need to push back and go beat up a vendor. Various enterprises kind of do that habitually. I'm looking at you, financial services. There's and you kind of wish
mention VPN providers, but yes.
Well, and you wish that healthcare did it too, but they'll take anything really. There's an opportunity here as we improve the lives of those sort of three personas to improve how they interact with each other as well. So AppSec engineers that are often sort of vilified by developers because it's just like, oh, here he comes with a big laundry list of things to fix. If they could provide more actual context, and remediation advice, and just shortcut the actual fixes to the point where it's just developers signing off saying, oh yeah, that was a bug, we can just click on this and approve a pull request. Make the tooling so that it's fully automated. If the AppSec engineer says, we've noted that this is uses a lot of dependencies that haven't been updated in a while. We'd like to enable runtime monitoring on your component and provide you with pull requests. Developers will be like, okay, as long as it's not onerous and not generating 100 pull requests a day. If a human being can't just click at it, look at it, and say, oh yeah, that's a quick fix, and the justification's right in it, then it's making more work than it should.
And if that pull request also passes at least whatever tests are in place, right, then that feels like a safer merge.
I know safe, people that work on code that will just use that very same criteria if the pull request was coming from a human. They'll look at it, they'll read it. They might not read it with the same level of, they're not going to read it for meaning too heavily. They're going to make sure everything they don't use any bad words, and the tests pass, and okay, I'm going to have to trust this guy. So if you can get the tooling to that level of trust, and that means a false positive rate of 92 to 95% accurate. Then maybe 1 out of 10 things, it's just maybe we don't need to fix that. At that point, you're pretty much blessing the changes automatically. I mean, there might be a human being in the loop, but the amount of effort is way lower. And I remember starting off when I started building tools at Veracode that the false positive rate was just given, by other companies like Fortify and whatever to be, 10% accurate and 90% FPs. It's just, you lived with that. And it gave this entire industry, the whole AppSec thing, a bad name. At no point should we have traded off, false positives for false negatives to that level. I would much rather miss a few things that a human being could find, given a sufficient time, than flood with all kinds of noise that nobody can, deal with it. That's a surefire way to get your tooling eliminated from the pipeline, and nobody needs that.
Definitely some reputational damage that AppSec itself suffered just because of that.
Yeah, absolutely. So how do you undo that? Well, you write tools that can naturally have a higher accuracy, but just in general not requiring humans to fear the output of the tool. Human beings need to just trust that their automated tools are doing the right thing. And
even better, here's a tool that solves something for us. So we're not even fearing, we're desiring, we're appreciating that output.
Exactly. We have ways of measuring application performance now in ways that we've never had in the past. Applications are long running, constantly changing, and how do you reconcile the use of static tooling with a dynamically changing application? That is the challenge for AppSec today. Nothing can become a science until you've perfected measurement and making changes and seeing if things are improving or not. Human beings are always going to be involved in the judgment process. We, in general, don't want to hand over the reins of quality, to the robots quite yet. At the end, there's always going to be some human, and in the case of security, it's often the CISO or in a pinch security engineering team. There's going to be humans that say, "Yeah, progress is being made in the right direction. Things are getting better." Now, if you can outsource that, companies like my company, Lacework, we have measuring, dashboards where you can look and you can see that green light that says, "Yeah, your security program is improving your posture over time." And we're looking at different ways of, displaying your security posture to you, through things like attack path analysis and, your code security and
that idea of information.
Yeah,
Here are signals for you.
Keeping the signal practical, for its audience, is going to help reduce the amount of touch points that those humans need to do when making judgment calls. But in the end, human beings are always going to be involved somehow. It's just about not burning them out. You give them what they need to know, where they need to know it, and give them all the justification they need to be able to make that judgment call quickly and apply, whatever, means necessary, a fix or a patch or a structural change to an organization sometimes, to make things work correctly. Give them all those tools.
I think that's a great summary. And because we have the science of chronometers is giving us the judgment call that it's time to bring ourselves to a close here. But
Sure.
One thing real quick before we leave, building a sort of yearbook this year of superlatives about AppSec. I'm just curious, if we have a page about AppSec is most likely to, how would you fill in that blank?
Application security is most likely to become a function of software quality. I think it's going to become highly general right now we see a lot of point analysis tools that look at little pieces of the problem, but they don't integrate. They don't use each other's data. They don't all speak the same language. Application security over time is going to become a more scientific discipline, with the data being a common language across all of the tooling.
Well, you've definitely brought a good quality conversation to us on this topic. And also, we appreciate you bringing the history that you have with source code analysis and the industry, AppSec industry in particular. So thanks again, Christien, for joining us.
I'm really excited about what the future is going to bring for AppSec.
Thank you. And let's stay excited. Thank you, everyone, for joining us. We're going to take a quick break now and return with news of the week.